Project 1.4, the 2-bit adder. The first part of this project is to build a half adder. The half adder uses two integrated circuits, or ICs for short. These chips are the 4070 and 4081, and they are used to perform the most basic addition in binary. Each input represents the number 1. When the red LED is on, a 1 is being presented, and when the green LED is on, a 2 is being presented. When both LEDs are off, a 0 is being presented. The half adder has only 4 combinations as there are only 2 inputs. Because there is not a third input to represent a previous carry, this circuit can only be considered a half adder. When input A is high, or 1, then the XOR will present a high to the red LED, and it will turn on. The same thing happens when input B is high. When both inputs are high, the XOR will present low to the red LED, and the AND will present high to the green LED. This means that when both inputs are high, or 1, then the green LED will turn on and present a 2. When only one of the inputs is high, then the red LED will turn on and present a 1. Finally, when none of the inputs are high, neither of the LEDs will turn on, thus presenting 0. The second part of this project is to build a full adder. The full adder can do the same simple addition as the half adder, but instead of only being able to reach a sum of 2, it can reach a sum of 3. The circuit is considered to be a full adder rather than a half adder because it includes an extra input that can represent a previous carry. This carry is referred to as carry in, or C-in for short, and it acts like an extra input, representing either the number 0 or 1. It should also be noted that the addition of this extra input requires one extra XOR gate and an extra AND gate. This circuit also includes a 4071 IC, or logic gate. This is used to add together the carry outputs that are produced from the two half adders to provide the final carry output. After the addition is done, the OR gate generates a carry that lights up the green LED. Because the full adder has 3 inputs, all representing 1, it can add up to 3. When the sum is on, 1 is being presented. When the carry is on, 2 is being presented. And if both are on, then 3 is being presented. And if both are off, it's a 0. The third part of this project is to build a 2-bit adder prototype. This 2-bit adder is able to perform simple addition in binary and can reach a sum of 6. The circuit involves one more input than the previous full adder and one more red LED. In this circuit, 2 buttons represent 1, and 2 buttons represent 2. This is important when considering the addition that can take place using this circuit. The LEDs represent the numbers 1, 2, and 4. These numbers also correlate with binary values, and the LEDs of this circuit should be placed left to right in descending value to represent the binary component of this circuit. The 2-bit adder also incorporates an extra set of XOR and AND logic gates. The added gates are the reason this circuit is referred to as a 2-bit adder. A pair of XOR and AND logic gates are referred to as a bit. The 2-bit adder is considered 2-bit because it has 2 pairs of XOR and AND logic gates and accounts for a previous carry. The final part of this project is to build a fully encased version of the 2-bit adder on a PCB. This adder works in the same way as the prototype, where 2 inputs represent 1s and 2 inputs represent 2s. The LEDs beside the switches show which switch is on and its value, with the switches on the left representing 2s and the switches on the right representing 1s. The bottom row of LEDs shows the sum of the circuit, in this case 4. Like with the prototype, this circuit can reach a sum of 6 in binary. Thank you for listening.